A very happy morning to you all children, and I wish you a very happy Diwali which is going to come very shortly. So be safe and enjoy your festival of lights. In today's lesson children, we are going to continue with the same topic, that is electricity, and we are going to see a new factor, that is resistivity. So we have seen all about resistance. So resistance is the obstacle in flowing of current through a conductor. So resistivity is the property. It is the property how much it will be interfering. So resistivity is the amount of resistance in the conductor. So that we are going to take up in today's learning, and it will have an equation, and we keep it by the letter rho. Rho is equal to RA by L. This is the formula. We are going to derive this formula, and finally we are going to solve some numerals on this concept. So children, listen to these slides very carefully, understand and get the ideas. Right? Now we will move into the lessons. Children, before going into the lessons, let us revise what we had done in the previous class, or let us revise the main concepts of what we had seen. First, let us take up resistance. Before resistance, let us see the definition of electric current. The electric current is a flow of electrons through a conductor. When the electrons move from one part of the conductor to the other part, they collide with each other and with the atoms and the ions present in the body of the conductor. Due to these collisions, there is some obstructions or opposition in the flow of electrons through the conductor. So when the electrons flow in a conductor, they are not flowing in a free manner like the flow of water. They get obstructed here and there due to the collisions between themselves and with the ions present in the conductor. Therefore, the flow of electrons is a little bit hindrance by its flow. So this property of the conductor, due to which it opposes the flow of current through it, is called resistance. The resistance of a conductor is numerically equal to the ratio of potential difference across its ends to the current flowing through it. Therefore, it has a formula: resistance is equal to potential difference divided by current, or R is equal to V by I. So where we represent resistance by R, potential difference by V, and current by I. Now let us see to the units of resistance. The SI unit of resistance is ohm. Ohm is the symbol, the bracket, the symbol for ohm is being given there. So how will you define 1 ohm? 1 ohm is equal to 1 volt by 1 ampere. This we get it from the resistance formula. Resistance is equal to potential difference divided by current. From there, if we take up the units, then 1 ohm is equal to 1 volt by 1 ampere. So from this, we can frame the unit, the definition of the unit of resistance. The resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when a potential difference of 1 volt is applied across its ends. So the definition for the ohm is very important. So how is ohm defined? The resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when the potential difference is of 1 volt. Right? Now let us see the conductors, resistors and insulators. So these are the branches where we can divide the main origin. On the basis of the electrical resistance, all the substances can be divided into 3 groups. They are conductors, resistors and insulators. Children, we have seen based on the resistance, substances are divided into 3, mainly as conductors, resistors and insulators. Now let us see the conductors, insulators and resistors. How is the property of the resistance in each? Now let us take up the first case, conductors. Those substances which have very low electrical resistance are called conductors. So conductors in short will have very low electrical resistance. A conductor allows the electricity to flow through it easily. Silver metal is the best conductor of electricity. Copper and aluminum metals are also good conductors. Electric wires are made of copper or aluminum because they have very low electrical resistance. Now we will see to the resistors. Those substances which have comparatively high electrical resistance are called resistors. The alloys like nichrome, manganese and Constantan or Eureka all have quite high resistance. So they are used to make those electrical devices where high resistance is required. A resistor reduces the current in the circuit. Then finally we will see about insulators. Those substances which have infinitely high electrical resistance are called insulators. An insulator does not allow electricity to flow through it. Rubber is an excellent insulator. Electricians wear rubber hand gloves while working with electricity because rubber is an insulator and protects them from electric shock. Wood is also equally a very good insulator. Children, in this slide, we are going to see about the factors affecting the resistance of a conductor. So on what factors the resistance depends upon? So resistance depends upon the following factors. 1. Length of the conductor, area of cross section of the conductor, which is nothing but its thickness. Third, nature of the material of the conductor. Finally, temperature of the conductor. So this is a very important board 2-mark question. What are the factors on which resistance depends upon? Length, area of cross section, nature of the material and temperature of the substance. Now let us go to the mathematical part of it. So we have seen in the first one, the resistance is dependent on the length. So it is, how is it dependent? It is directly proportional. That means when length increases, resistance also increases. So the resistance of a given conductor is directly proportional to its length. R is proportional to length. Now let us keep it by equation number 1. The resistance of the given conductor is inversely proportional to its area of cross section. So let us keep the area of cross section as A. Obviously, the area of the cross section of the wire, since it is cylindrical in shape, it will be circle. So R is proportional to 1 by A. 1 by A indicates it is inversely proportional. It means when the area increases, resistance decreases and vice versa. Now let us keep this as equation 2. Now let us combine equation 1 and 2 together. So R is proportional to L by A. Now when we remove the proportionality sign, we normally add equal to sign with a constant. This constant we represent with the symbol as rho. It is a Greek letter rho. So where rho is a constant and it is the specific resistor of the conductor, or we simply say resistivity of the material. So R is equal to rho L by A is a very important mathematical equation. From this we can find out the equation for rho. So rho is equal to RA by L. So if you are asked to find out the specific resistance of a material, we have to use the formula rho is equal to RA by L, where R represents the resistance, A represents the area of the conductor, which is mathematically given by the formula pi r square, where R represents the radius and L represents the length of the conductor. Children, let us design an experiment in order to study the various factors on which resistance depends upon. So in the previous slides, we have seen that resistance depends upon 4 main factors. They are length of the conductor, area of cross section of the conductor, nature of the material, and finally the temperature of the material. Now let us take one by one and see and analyze each factor. First, let us take the length of the conductor. The resistance of a conductor is directly proportional to its length. What does it mean? Since the resistance of the wire is directly proportional to its length, when the length of the wire is doubled, then the resistance also gets doubled. Or else even we can say when the length of the wire is halved, the resistance also becomes half. Second factor, area of cross section of the conductor. The resistance of a conductor is inversely proportional to the area of cross section. Since the resistance of a wire is inversely proportional to its area of cross section, that is, when the area of cross section of the wire is doubled, then the resistance gets halved. Or if the area of cross section of the wire is halved, then the resistance will get doubled. Third one, nature of the material of the conductor. The resistance of a conductor also depends on the nature of the material of which it is made. Some materials have low resistance, whereas others have high resistance. Finally, the temperature. Resistance of a wire depends on the temperature. Since the material is different, temperature developed in the circuit also will not be the same. It will vary according to the nature of the material that we choose. Now let us Put all these factors in one simple experiment and let us try to analyze each factor. Now here is an experiment. You see to the circuit diagram here. The circuit diagram consists a cell, an ammeter and a key, and number 1, it is a nichrome wire of length L is connected in the circuit. Inside the square box you can find number 2, number 3 and number 4. Number 1 you can see on the right side, it is of nichrome wire of length L. Case 2, it is given as case 1, but below case 1 it is case 2, wire of length 2L. So you can see double the length of the same nichrome wire. The third case is wire of double thickness, same length with double thickness. Now fourth case is of different material, wire of copper. So we are going to insert the first wire, then the second wire and the third wire, finally the fourth wire, and we will be analyzing the result of this experiment. So let us go into the experimental setup now. So experiment to show that resistance of a conductor depends on its length, cross section, area and nature of its material. Complete an electric circuit consisting of a cell, an ammeter, a nichrome wire of length 2L, nichrome length L, that is number 1, and a plug key, all shown in the figure. So number 1 is a nichrome wire of length L. So number 2 is replace the nichrome wire by another nichrome wire of same thickness but twice the length, that is 2L, marked as 2 in the figure. Now note down the ammeter reading. In the third case, similarly, you are going to replace it with wire of double the thickness. So in the third case, now replace the wire by a thicker nichrome wire of the same length L. A thicker wire has a larger cross-sectional area. Again, note down the current through the circuit. Then instead of taking a nichrome wire, connect a copper wire marked as 4 in the figure in the circuit. Let the wire be of the same length and same area of cross section as that of the first chosen nichrome wire. Note down the value of the current. Notice the difference in the circuit in all the case. So the ammeter reading in each of the cases will give us the result. Now children, predict your ammeter values. How will be the ammeter value when you connect number 1, then replace it by number 2, then replace it by number 3 and replace it by number 4. So you think and analyze. Now we will see how would be the ammeter reading in the next slide. Now let us see to the result of this experiment. How will be the ammeter reading? Ammeter reading gives you the value of the current, right? So ammeter or current reading varies inversely with the changes in length of the wire. For example, if we double the length of the wire, the current reduces to half. Ammeter reading changes with the change in the thickness of the wire. For example, if we increase the cross-sectional area of a wire by double, its resistance will be half. So it is observed that the ammeter reading decreases to 1/2 when the length of the wire is doubled. The ammeter reading is increased when the thicker wire of the same material and of the same length is used in the circuit. A change in the ammeter reading is observed when the wire of different material of same length and same area of cross section is used. So on applying Ohm's law, that we observe that the resistance of the conductor depends on its length, on its area of cross section, and on nature of the material. Precise measurements have shown that the resistance of a uniform metallic conductor is directly proportional to its length and inversely proportional to the area of cross section of the conductor. Children, we will see about the Roman letter rho, that is resistivity, with this slide. So we have seen the formula for rho. So rho is equal to RA by L, where R represents resistance, A represents the area of cross section, and L represents the length of the conductor. By using this formula, we will now obtain the definition of resistivity. Let us take a conductor having a unit area of cross section, that means 1 meter square, and a unit length of 1 meter. So substituting A equal to 1 and L equal to 1 in the above equation, we get rho is equal to R. So resistivity is equal to resistance. The resistivity of a substance is numerically equal to resistance of the conductor, where the substance has 1 meter as its area of cross section and having 1 meter as its length. So based on these two conditions only, rho will be equal to R. So let us see to the definition. The resistivity of a substance is numerically equal to the resistance of a rod of that substance, which is 1 meter long and 1 meter square in cross section. So let us see about the units of resistivity. So rho is equal to, substitute in the formula, RA by L. R has a unit ohm, A has a unit meter square, L has a unit meter. Therefore, when you simplify, ohm meter. So ohm meter is the SI unit of resistivity. The SI unit of resistivity is ohm meter, which is written in symbol as ohm meter. Resistivity of a substance does not depend on its length or thickness. Depends only on the nature of the substance. The resistivity of a substance is the characteristic property. So we can use the resistivity values to compare the resistance of the substances or materials or conductors. Children, in this slide, let us discuss about two factors. One is importance of resistivity and the effect of temperature on resistivity. First, let us take the importance of resistivity. A good conductor of electricity should have a low resistivity, and a poor conductor of electricity should have a high resistivity. The resistivities of alloys are much more higher than those of the pure metals. It is due to their high resistivities that manganese and Constantan alloys are used to make resistant wires used in electric appliances to reduce the current in an electric circuit. Nichrome alloy is used for making the heating elements of electrical appliances like electric irons, room heaters, water heaters, and toasters, etc. because it has very high resistivity and it does not undergo oxidation, that means burn, even when red hot. So this part of the concept is a very important concept where frequently asked in the CBSE exam. Why are alloys used as heating elements? So the reason is there are two reasons. They have high resistivity and they do not easily undergo oxidation. That means they don't catch fire when they are red hot. So due to these two reasons, we choose nichrome alloy as the heating element. Now let us move on to effect of temperature on resistivity. The resistivity of conductors like metals is very low. The resistivity of most of the metals increases with temperature. On the other hand, the resistivity of insulators like ebonite, glass and diamond is very high and does not change with temperature. The resistivity of semiconductors like silicon and germanium is in between those of conductors and insulators and decreases on increasing the temperature. Semiconductors are providing to be of great practical importance because of their marked changes in conducting properties with temperature. This slide gives some of the uses of the conducting materials that we use in our day-to-day life. First, tungsten. It has high melting point of 3000 and odd degree Celsius and emits light at 2000 and odd degrees Celsius. It is thus used as the filament in bulbs. Nichrome. It has high resistivity and melting point. So it is used as an element in heating devices. Constantan and magnanin. They have modulated resistivity. Thus, they are used for making resistance and rheostats. Thin alloys, it has low resistivity and melting point. Thus, it is used for fuse wires. Now you have a numeral based on this one. When a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliamperes in the circuit. Find the value of the resistance of the resistors. So given the voltage is 12 volts, current is 2.5 milliamperes converted into ampere, so multiplied by 10 to the power minus 3. Substitute the values in the formula R is equal to V by I, so you will get the answer for this. Children, now let us move on to solving the numerals. Now I have taken up the example 12.5 from your textbook, which is based on resistivity. To find resistivity, that is Roman letter rho. So rho has a formula Ra by L. All this you have to remember. Right, let us see to the question. Resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 mm, that is millimeter. What will be the resistivity of the metal at the temperature? Using table 12.2, which is in your textbook, predict the material of the wire. Fine. Now, the first part of the question is we are asked to find out the resistivity, that is rho. So, rho has a formula Ra by L, where R is given as 26 ohms, and for area we are being given diameter as 0.3 millimeter. So diameter is 0.3. So we actually need the value of R. R is equal to D by 2. Radius is equal to diameter divided by 2. So substitute in the formula pi R square. Then it will become pi D square by 4. So Ra by L will become R pi D square by 4L. Now D is in millimeter, that you have to convert it into meters. So 0.3 millimeters will be 3 into 10 to the power minus 4 meters. So substitute all these values in the formula, get the answer. So you should get 1.84 into 10 to the power minus 8 ohm meter. So the calculation of this is little tricky and needs lot of your concentration. So work out carefully. If you don't get the answer, try to contact me. I will help you. By this, we come to the end of today's learning session. So we had seen about resistivity, factors affecting resistivity, and the SI unit of resistivity, and solving some numerals. So as a part of today's learning, I will give you an assignment which contains numerals. So where you have to solve this. Secondly, go through your textbook and learn the concepts until we have learned. And in the final class, that is the next week class, I hope we will be completing this chapter, and I will give you the NCERT solutions one by one and step by step. Also children, I will be giving you some 10 3-mark questions in almost all the chapters, which you have to learn it by yourself, and you have to write it in a ruled paper, and you have to share it to me with a snapshot. So children, all the best and enjoy your festival of lights. Bye to you.